welcome to this explainer. Look, nobody wants to read through hundreds of pages of dense Kubernetes PDFs step by step just to figure out how it works. So we're skipping all that. We're going to cover everything you need to know from those manuals right here. If you're a focused learner looking for a complete, concrete mental model of Kubernetes without drowning in heavy jargon, you are in exactly the right place. Today, we're unpacking what this technology actually is and why it has completely taken over how we run applications. I promise, by the end of this, you'll have a rock-solid understanding of K8s.
Here's our roadmap for today. We'll start with the core mental model, see Kubernetes in action, check out the Minikube flight simulator, dive into real-world production clusters, and finish up with a highly pragmatic setup strategy.
All right, let's dive right into part one, the core mental model, and how we need to rethink how apps actually run.
At its core, Kubernetes, or K8s as we usually call it, is essentially a system that runs your app's containers across a bunch of machines and keeps them healthy. Think of it like an orchestra conductor, or honestly, a highly efficient babysitter. It automatically restarts crashing apps, moves things around if a machine completely dies, and scales your app up or down. And the best part? It literally does this forever, without a human ever needing to watch it 24/7.
Think of a normal app like a light switch. You flip it on, and it stays exactly where it physically is. If the power cuts out and comes back, the switch doesn't care. Nobody is watching it. But Kubernetes is way more like a thermostat. You don't tell a thermostat, hey, turn on the heater. You just declare, I want this room to be 22 degrees. If a window opens and it gets cold, the thermostat automatically notices that difference and fixes it. It keeps checking over and over again.
To really lock in this mental model, let's quickly define our terms. First up is the container. This is simply your app packed into a neat little box that runs the exact same way anywhere. If you've used Docker, you know exactly what this is. This is the thing we're actually running. Next is the pod. A pod is just Kubernetes' specific name for one running copy of your container that happens to be alive right now. Just think of it as a single active instance of your application. Then we have the deployment. This is an instruction file written in YAML that tells the system exactly what you want. It might say something like, hey, keep 2 pods of this backend app running at all times. Going back to our analogy, this deployment is effectively your thermostat setting. It's where you declare exactly what you want to be true. And finally, the Kubernetes control loop. This is the background program that constantly reads that deployment file and literally forces reality to match it. It's the internal circuit of that thermostat. It checks every few seconds, forever, to make sure your promise is kept. You don't ever run this yourself. It's just always grinding away behind the scenes. Okay, moving on to part 2, Kubernetes in action. Let's look at some real-world scenarios. When you compare the normal way of running apps to the Kubernetes way, notice the massive difference here. Whether you're starting an app, dealing with a random crash, or rolling out a new update, Kubernetes never requires a person to manually intervene. If a whole server dies, a normal app is offline until you fix it. Kubernetes? It just seamlessly spins up your app's copies on a totally different, healthy machine. Picture this. It's 2 a.m. Your app crashes hard from a memory issue. Without K8s, you're waking up, grabbing your laptop, digging through logs, and manually restarting it, while users stare at a broken app for 20 minutes. But with Kubernetes, within seconds, it notices a pod is missing and starts a fresh copy automatically. And since your deployment declared you want 2 copies running, that second replica easily handles the traffic during those few seconds of downtime. Your users probably won't even notice a blip. Or what about a sudden massive flood of traffic? So your app goes viral and traffic jumps 5x. Normally, things would just slow to a crawl or crash entirely. But in Kubernetes, there's a feature called the horizontal pod autoscaler that actively watches your usage. It sees the spike and automatically starts extra copies. And crucially, when that traffic drops back down, it removes those extra copies so you aren't stuck paying for them. Again, nobody gets a frantic phone call. If you take just one thing away from this explainer today, let it be this. A normal app only does what you tell it to do right now, once. But a Kubernetes app is told what you want, and something keeps making that true, over and over, forever. That is the fundamental promise K8s makes to you. Every file you write isn't a command, it's a promise Kubernetes keeps. Let's shift gears to part 3, the Minikube flight simulator and local testing. So Minikube is basically one single computer pretending to be an entire Kubernetes cluster. It installs the whole K8 software stack inside one Docker container or a small VM right on your laptop. It's an absolutely brilliant flight simulator for learning because it teaches you all the controls perfectly.
But much like a flight simulator, you would never put actual paying passengers or production apps on it.
And why shouldn't you use it for production? Well, by squeezing everything into one machine, Minikube creates the exact single point of failure that Kubernetes was literally invented to solve. If your laptop dies, the whole cluster goes with it. On top of that, it fakes load balancers, restricts real network access, and if you ever delete Minikube, any database storage saved inside it is instantly wiped out. But here's the good news. About 90% of your configuration files, all that YAML you wrote, stays exactly the same when you transition to a real production environment. You only really change the edges to meet reality. So you'll push images to a real registry like Docker Hub, use actual cloud load balancers to get traffic in, point your storage classes to real cloud desks like AWS EBS, and use proper secret managers so your passwords aren't sitting around in plain text. Now, if you want to move past Minikube and getting much closer one-to-one simulation of real production on your local machine, there are some great alternatives. You've got K3s or K3D, which are real certified lightweight K8s distributions. You can use Kind, which runs Kubernetes inside Docker, or even spin up multiple VMs and use Kubernetes to join them manually. Honestly, using K3s locally is an excellent, highly pragmatic next step. That brings us to part 4, real-world production clusters and their architecture. In reality, a Kubernetes cluster is split into 2 distinct parts across multiple machines. First, there's the control plane. Think of this as the brain. It watches for problems, maintains your desired state, and decides what runs where. Then you have the worker nodes. These are the muscle, the actual servers running your application pods. You can absolutely pay a cloud provider like Amazon EKS to manage the brain for you, but that control plane fee alone is about $73 a month, flat, before you even spin up a single worker node.
Which leads us nicely into part 5, your pragmatic setup strategy, focusing on keeping things in-house and cost-effective.
Here is the golden rule for cost-conscious infrastructure. Stateful, data-holding services like MongoDB or Kafka, they are notoriously difficult to run well inside Kubernetes. If you mess up, you literally lose user data. So the most pragmatic approach is to keep those databases safely outside the cluster on a plain virtual machine or just use a managed service. Then put your stateless applications like your Node backend or React frontend inside a lightweight K3s cluster. That way you get all that self-healing magic right where it's safest and easiest to manage.
Let's actually break down these costs. If you run a single EC2 instance with no Kubernetes, you pay a base cost but get 0 self-healing. If you run K3s on that exact same instance, it costs you basically $0 extra, but suddenly you get self-healing pods and awesome configuration management. Want some real hardware resilience? Running 2 to 3 small EC2s with K3s might run you $30 to $70 a month. Compare that to a managed EKS setup, which easily starts around $150 to $250 minimum. A self-hosted K3s setup gives you the real power of Kubernetes at a total fraction of the price. So we've covered a ton of ground, from the absolute basics to some highly pragmatic, cost-saving architectures. I'll leave you with this final thought. Take a hard look at your own setup right now. Is your infrastructure acting like a fragile light switch, just waiting to get bumped in the dark? Or are you ready to upgrade to a self-healing thermostat using K3s? Thanks so much for joining me for this explainer, and I really hope this mental model helps you build stronger, more resilient apps.